In today's video, we will learn about Bohr's atomic theory of atom. So, this model of atom was developed by Danish physicist Nobel laureate Niels Bohr in 1913 to overcome the drawbacks of Rutherford model of atom, right? So, Bohr have some assumptions regarding this theory of atom. So the assumptions are first that electron revolve around the nucleus of the atom in a circular path known as the orbit. So this is the first assumption of Bohr model of atom. Second assumption is out of the several possible circular orbits, the electron is allowed to move only in a certain discrete orbit, right? Now the third assumption is while moving in an allowed orbit, the electron is associated with a determined or defined amount of energy. That means the orbits in which the electron is revolving is a fixed energy orbit. Therefore, these orbits are called the energy levels or shells. The orbit or the energy levels are designated by the letter K, L, M, N, O, and so on. Or we can say that 1, 2, 3, 4, 5 shells. Now here the first orbit is the K shell and is the nearest to the nucleus. That means if this is a nucleus that is positively charged, so the nearest shell is the K shell, right? And the energy sequence of this orbit or shell is as follows. That is K, then L, then M, then N, and then O. Or we can say that 1, 2, 3, 4, 5, and so on. Now, the fourth assumption of this theory is that as long as the electron revolves in the allowed energy levels or the shell, it does not radiate energy. That means that during revolution of electron, it is not emitting any energy or any radiations. That means the energy of electron remains constant while moving in a particular allowed orbit, right? Here, the fifth assumption is when an electron jumps from lower energy level to a higher energy level, it absorbs energy, right? But when it jumps from a higher to lower energy level, that means it is emitting its energy. That means it is losing its energy. You can see here in this image when an electron is moving from a higher orbit to a lower orbit. That means here energy is released, and when an electron is moving towards a higher energy level, it is absorbing the energy, right? Here we can say that electron makes a transition from one orbit to another orbit. Here energy is gained and lost in definite discrete packets called the quantum or the photons, right? Now moving towards the distribution of electrons in various shells and their electronic configuration. So atoms of different element have different atomic numbers. We know that different elements have different atomic number and therefore they have different number of electrons also, right? Therefore the distribution of these electrons in different orbits or the shells is called the electronic configuration of atom, right? Here Bohr-Bury scheme of electron distribution. So here scientists Bohr and Bury in 1921 independently give the electronic distribution, or we can say that the electronic configuration of elements on the basis of certain rules. Here the first rule is the maximum number of electrons that can be accommodated in an orbit or a shell is equals to 2n square, where n is the number of the shell. That means if the electron is in first cell, that means the n will be 1, right? And when we do the calculation of this, that is 2n square, that is 2 into 1 square, that comes out to be 2. That means 2 electrons are the maximum number of electrons that can be filled into first cell, or we can say that the K shell. Here you can see the calculation. Electrons in the first shell, that is the K shell, is 2. In the second shell, that is the L shell, here 8 electrons can be accommodated. Then M shell can accommodate around 18 electrons and N shell can accommodate around 32 electrons. You can see here different shells, that is K, L, M and N, and their electron capacities, right? Now moving ahead, second point is the outermost orbit or the outermost cell can have a maximum number of 8 electrons according to the octet rule, right? Now the next inner to the outermost, that is the penultimate shell, can have 18 electrons if permissible by the 2n square rule. Here, for example, the atomic number of calcium is 20. That means that it may have 20 electrons. That means the first cell will have 2 electrons, the other cell will have 8 electrons, and the outermost shell that can accommodate 18 electrons, but it will have only 8 electrons in it, and the outermost, the last cell, will have 2 electrons. That's why the calcium electronic configuration is 2882, not 2810. Right? Here, the third point, it is necessary that to get a shell completely filled before starting the filling of the next higher shell. Actually, when there are 8 electrons in a shell, the filling of the higher shell can start. Here, the outermost shell cannot hold more than 2 electrons, and the penultimate shell cannot hold more than 8 electrons unless the preceding inner shell is completely filled according to the 2n square rule, right? Thus, the shells are filled in stepwise manner. You can see here the electronic configuration of some elements. That is the electronic configuration of some elements. You can see here electrons in different shells. As hydrogen has one proton in the nucleus and only one electron in the K shell. Here is helium that has two electrons in the K shell. Then we have different elements. For example, boron and carbon. Both have two electrons in the innermost or K shell, and then boron has 3 electrons in the L shell while carbon has 4 electrons. Now this filling goes on. Nitrogen will have 5 electrons in the outermost, and oxygen will have 6 electrons in the outermost shell. Fluorine will have 7 electrons in the outermost shell. Here neon, that is a noble gas, will have maximum, that is the fulfilled shell, that is the 8 electron state of outermost shell. So this is the electronic configuration and filling of electron in different elements and shells. So I hope this topic is now clear to you. Thank you.